Alrighty, so what we're doing today is we're looking at circles. So we have lots to do with with the equation of a circle and how we can graph circles on our number planes and our Cartesian planes. We have looked at these back in year 10, so hopefully they ring a bell, but we will go through them anyway just to show you what everything is. So the equation of a circle is not a function as it doesn't pass the vertical line test. So what we have is our circle with a centre 0, 0. We can use Pythagoras' theorem to find the equation of a circle using our general point x, y on our circle with a centre 0, 0 and a radius r. So what we have using Pythagoras' theorem is our c squared equals a squared plus b squared. On our triangle over here, we have our c is r, our a is x, our b is y. So that means that we'll have r squared equals x squared plus y squared. Now that looks a little bit funky, so what we're going to do is we're going to flip it so that the equation of a circle with centre 0, 0 and radius r is written as x squared plus y squared equals r squared. So what we have for our first example. Our first example here is to sketch the graph of x squared plus y squared equals 4 squared. So this is in the form of x squared plus y squared equals r squared. So what we have is we have that r squared is equal 4, so our radius is equal to 2. So what we do is we put a dot on our axes at every plus or minus 2 value, and we draw a circle going through those points, okay? A circle as to the best of our ability. Whoops. Okay, going through those points. Now, our next part of our question is asking us why this is not a function. So this is not a function because our vertical line will pass through twice, so more than once, in our graph. So we're going to write the circle is not a function as a vertical line will cut the graph in more than one place. Okay, so it doesn't pass that vertical line test that we have for functions. Okay. What we have for part C is we want to state its domain and range. So remember, our domain is all the x values it can be. So our domain goes from -2 to +2. Our range is all the y values it can be, and it goes from -2 to +2. Does that make sense? Cool. Flip the page when you're ready and we'll go through our next example. So that's to do with circles that have a centre of 0, 0. So because we had our centre right in our middle point at 0, 0, we also can translate circles around our axes, okay? And they will have a centre at the point AB. So again, we can use Pythagoras' theorem to find the equation of a circle with our centre AB and a general point x, y with a radius of r. What we have is that the smaller sides of the triangle are x minus a and y minus b. Okay, so what we have is that using our Pythagoras' theorem, so our c squared equals our a squared plus b squared. So c is r, x is minus a, and y minus b is our b value. What we will have is r squared equals x minus a all squared plus y minus b all squared. Okay, again, that looks a little bit funky. So what we do is to write the equation of a circle with our centre AB and our radius R, we write out, bless you, x minus a all squared plus our y minus b all squared equals our r squared. Now, that formula is on our reference sheet. So that is awesome. We don't have to remember that formula. We just need to know how it works. Okay, so it is the equation of our circle, just translated a units to the right and b units up. If we quickly jump to our reference sheet, it is in our relations section. So it is here. It is our equation of a circle. With centre AB, radius R. Okay, if we had a centre of 0, 0, that means our A is 0, our B is 0. We can still use that formula for our equation of a circle if we forget as well. Okay, so that is on our reference sheet and we can annotate our reference sheet. So our next example, we want to sketch the graph of the circle x minus 1 all squared plus y plus 2 all squared equals 4. Okay, so what we have with this is in our form of x minus a squared plus y minus b squared equals r squared. Okay, what we have is our a is equal to 1. Our b is equal to minus 2, and our r is equal to 2. Should have given you more lines, but that's okay. So therefore, our centre is going to be at the point 1 minus 2, and our radius is equal to 2. Okay, the reason why the b value is negative is because we have a positive inside our brackets, and it's the opposite of it. So how we sketch this circle is we put a point at our centre, so 1 minus 2. Then from that point, we go directly up to, put a dot, directly east to, put a dot, directly south to, put a dot, directly west to, put a dot. That's where our radius is if we go around 90 degrees. From there, what we can do is we can sketch our circle. So going through all those points, we can sketch our circle. Obviously, I can manipulate my circle a little bit more compared to you guys. Yeah, that's okay. Just do it the best that you can. Maybe it's a good idea to use a pencil to draw it a couple of times and then go over it in pen. Okay, it's a lot of practice sketching your circle. The one thing when we sketch our circle, we need to include our centre on our circle. Okay, we will have lots of practice of sketching circles today, so don't stress. All right, and we're going to write our equation on there as well. Now, our next part is to work out its domain and range. So, with our domain, remember our domain is all of our x values. So, our domain, our smallest x value is there at minus 1. Our largest x value is there at 3. So, that means our domain is from -1 to 3. Our range is the y values it can be. So our range, our smallest y value is -4 and our largest y value is 0. So that means our range is -4 to 0. Now we do our square brackets because it includes all of these points. Okay, moving on to our next example. So our next example is about finding the equation of a circle with our radius 3 and our centre -2, 1 in expanded form. So what we have is that formula that is on our reference sheet, x minus a all squared plus y minus b all squared equals r squared. Now, what we have to do from here is we have to substitute in both our centre and our radius into this to get our circle. So what we're going to do is we are going to let a equal -2, b equal 1, r equal 3. We're just going to write that off to the side. That is because our centre has -2, 1 and our radius is 3 from our question. So when we substitute those in, we'll have x minus -2 all squared. Now, what happens with our -2 all squared? It turns into a positive. So let's make that a big positive. Oops, what happened there? Plus y minus our b value of 1 all squared equals our r, which is 3 all squared. What we need to do from here is the question is asking it for an expanded form. So if you know your perfect, what are they called? Perfect squares expansion, you have a plus b all squared is equal to a squared minus, 2ab plus b squared, or you have a minus b all squared is a squared minus 2ab plus b squared. So some of us would be able to jump a few lines and go that this is expands to x squared plus 4x plus 4 for our first one. Okay, so x plus 2 all squared, using our perfect squares formulas, expands to x squared plus 4x plus 4, plus our y minus 1 all squared, it expands to y squared minus 2y plus 1 equals 9. Now, not all of us sitting in here is going to be able to remember and use our perfect squares formula. So if you can't, what you need to do is x plus 2 all squared is just x plus 2 times x plus 2. Y minus 1 all squared is y minus 1 times y minus 1 equals our 3 squared of 9. From there, you can expand the brackets to get x squared plus 2x plus 2x plus 4 plus our y squared minus y plus 1 equals 9. Okay, so if you don't remember your perfect squares, you need to use your double brackets. Obviously, being efficient, it helps to know your perfect squares formulas and be able to do it quickly. That's why it was so important back in topic 1 when we expanded using perfect squares. Now, to get it in expanded form, we want it to equal 0. So what that means is we need to minus 9 from both sides. So what we will have is x squared plus 4x plus y squared minus 2y. Now, what we have is we have these 4 plus 1 and our minus 9. So what we want to do is we want to collect all constants, all constant terms. Okay, so what we're doing is we're going 4 plus 1 minus 9, and what that equals is negative 4. So what we will have is a minus 4 there equals 0. So that is how we are doing it nice and quickly and efficiently, is we're looking at collecting like terms, so our constant terms are like terms, so we can put them all together like so. Okay. Our last question here is to find the centre and radius of the circle with our equation x squared plus 2x plus y squared minus 6y minus 6 equals 0. Okay, so what we're going to do is, this is an expanded form. We're going back into the form of the equation. We're going to write out what we've been given to start off with. So we're going to write out x squared plus 2x plus y squared minus 6y minus 6 equals 0. What we're going to do is we're going to plus our 6 to the other side. Now, we need to get this back into x minus a all squared plus y minus b all squared. So what we have to do is complete the squares. Again, something that we did earlier on in our algebra and equations topics is coming back in. Okay, so this is why some of that was such good foundational knowledge. So to complete our squares, we'll have x squared plus 2x plus leave a gap, plus y squared minus 6y plus leave a gap equals that 6 that we've added to the other side. Okay, now we have to complete the squares for our x's, then we have to complete the squares for our y's. When we complete the squares for our x's, what we do is we'll have x plus half the coefficient of x. So our coefficient of x is 2. What's half of 2? 1. So we'll have x plus 1 all squared there. Okay, what we have to do is we have to square the 1 and add it back. And then whatever we put in there, we have to add to the other side. So we've got to add the 1 to the other side. Then we have to complete the squares for our y's. So we write it as y, and then we have to halve the coefficient of negative 6. So half of negative 6 is negative 3 all squared. Okay, so then what we have to do is add negative 3 squared back up and add it to both sides. But what is negative 3 squared? 9. Okay, so I'm going to have that it's my negative 3 squared on the left-hand side, but I'm going to put a 9 on the other side, just to help me out in a moment. So then what we have that our x plus 1 all squared plus our y minus 3 all squared equals is 6 plus 1 plus 9, which is 16, because we can use our friends of 10 to do that nice and quickly. Okay, then what we want to do is we want to rewrite this so it is in the form of x minus a all squared plus y minus b all squared equals our r squared. So our left-hand side is fine, our x plus 1 all squared plus our y minus 3 all squared. It will then equal, if 16 equals r squared, it will be 4 squared. Okay, so what this means is that therefore our centre is negative 1, positive 3, and our radius is equal to 4.